Today we will discuss another coordinate system, that is spherical polar system. We know that in this system the three coordinates are r, theta and phi, where r is radial component, theta and phi are angular components. These components are shown in this figure. If you see in the figure, this is Cartesian coordinate system, that is x, y, z axis. Let a point P in the space and OP become r vector. So, this r is the first component of spherical polar system. The angle between this r vector and z axis is theta. Now, the projection of this OP vector in xy plane, that is in the basement, this plane, this is the projection of r vector. The angle between this projection and x axis is phi. So, this is third coordinate or third component of spherical polar system. This is r, theta and phi. If we consider the directions of these components, these vectors, then r cap, theta cap and phi cap are the unit vectors which represent the direction of these components. It is similar to I cap, j cap and k cap in Cartesian coordinate system. So, the direction r cap is this, that is, it is the extension of r vector. This is r cap, that is direction of r. Similarly, the arc, this corresponding to this theta angle is called theta cap. Similarly, the arc corresponding to this phi angle is called phi cap. So, this is collectively r cap, theta cap and phi cap. These are three mutual perpendicular axes which is spherical polar unit vectors. Now, we will discuss the various physical quantities, or we will describe the various physical quantities in both Cartesian as well as spherical polar system. So, these are the 5 physical quantities, that is position vector or displacement vector, second one velocity, third acceleration, fourth one area element and fifth one volume element. So, these are the 5 physical quantities we will describe in both systems. So, first we will consider Cartesian coordinate system. In the first part, I will discuss this system, that is two-dimensional system, that is we will take only two axes, x axis, y axis or y z or z axis. So, here I am using the two axes x and y axis, these are. So, this is two-dimensional Cartesian coordinate system. This is point O, that is origin, and particle P is lying in this plane. The vector corresponding to this point P from O, this is r vector, and this is called position vector, that is our first parameter. So, we have already studied this position vector in Cartesian system in the lower classes, that is, if you draw perpendicular from P point on x axis, then it is x component. Similarly, the projection of or perpendicular of P point on y axis is y component. So, these are two components x and y of r vector. So, we may write this r vector as r vector is equal to xi plus yj, and its magnitude is x square plus y square under root. Similarly, second point, velocity. We know that velocity is the rate of change of position or displacement with respect to time, that is v is equal to dr upon dt. Putting the value of r, that is this value, in this equation, we will get v is equal to ddt of this value of r, x I dot I cap plus y j cap. So, on separating these variables for derivative, we will get dx upon dt I cap plus dy upon dt j cap, where I and j, these are not variables, these are constants. So, we may write this dx upon dt is x dot, similarly dy upon dt is y dot. So, the equation for velocity become x dot I plus y dot j, and hence its magnitude is x dot square plus y dot square under root. So, it is same just like as the position vector. Now, third parameter is acceleration. We know that the rate of change of velocity with respect to time is called acceleration, that is a is equal to dv upon dt. Again, on putting the value of v here, we will get dt of x dot I plus y dot j. So, again the derivative may be written as dot. So, there are double dot, one dot is already here and second dot due to this dt. So, it is second derivative of x, that is x double dot I plus y double dot j, and hence its magnitude become x double dot square plus y double dot square under root. Now, next parameter is area element, fourth parameter, this one. This is area element. So, we know that area is the cross product of two vectors, that is dA vector is equal to dxi cross multiply with dyj, and if we consider its magnitude, then it will become dx into dy and I cross j. We know that I cross j is equal to k, but we will not use this I cross j is equal to k because we are studying two dimensions. So, there is no third dimension. We will not consider the direction, we will consider only its magnitude, that is dx into dy. We will consider this direction in the next three dimensional system. So, this is all about two dimensional system in Cartesian coordinates. Now, in 3D, the second part, same the 5 parameters, that is position vector, velocity, acceleration, area element and volume element in this system. We know that in 3D this r vector may be written as xi plus y dot yj plus zk, and its magnitude become x square plus y square plus z square under root. Similarly, velocity is the rate of change of r, and putting the value of this r here, we will get x dot I cap plus y dot j plus z dot k, and its magnitude x dot square y dot square plus z dot square under root. Similarly, acceleration is the rate of change of velocity. On putting the value of velocity in this equation, we will get x double dot I plus y double dot j plus z double dot k, and corresponding its magnitude x double dot square y double dot square z double dot square under root. Now, the fourth one is area element. So, we know that area is the cross product of any two vectors. In the first case, I will consider these two x and y components. D means small components, that is element, element means small component. So, dxi cross dyj. So, it will become dx dy, these are the magnitude, and I cross j is equal to k, we know that in right handed system. So, this area element become dx dy into k cap. So, from this formula it is clear that this area is directing towards k means z axis. So, this is dAz. So, I have written this area element along z axis. Similarly, we can calculate dAx and dAy. That is, dx is dy dz and direction is I along x axis. Similarly, in case of day, the components are dx into dz and direction is along j, that is y. So, these are the different figures for these area elements. If we see in the diagram, this is x axis, y axis, z axis. So, this is dx and this one is dy and this element is dx dy, but its direction is along z axis. So, this area element represent dAz. Similarly, it is dAx because it is consisting of dy and dz vectors, magnitudes, but the direction is perpendicular, that is x, and hence similarly dx dz it is day because its direction is directing towards y side. Now, the fifth one is volume element. We know that volume is the scalar triple product, that is A dot B cross C. So, A means dxi, B means dyj and C means dzk. So, first dot second cross third. So, first of all we will solve this dy and dz, then after that to multiply with dxi. So, here it is dy dz, j cross k is I cap and then dxi as it is written here. So, on solving this overall it is dx dy and dz, I dot I is 1. So, it is volume, volume means scalar quantity, there is no any direction in volume. So, this volume can be represented in diagram by dx dy and dz. So, this is the volume of cuboid. So, this is all about these 5 physical quantities in Cartesian coordinate system. In the next lecture, we will again study these 5 parameters, these 5 physical quantities in spherical polar system. Thank you very much.